Hey everybody, welcome to this video. This is a video for module 18, which has to do with using equations to solve word problems. We're going to go through just a couple of examples in this video to help kind of show you the process of setting up equations based on a word problem and then solving them to come up with what the solution is to the original problem. So with that, I will share my screen and we'll get started with the examples. So here we go. Let's go ahead and jump into the first sample problem. Excuse me. Sample problem number one. We want to solve the word problem. So I'll give you a minute here to look at the problem on your screen and read through it. All right, so basically what we're trying to figure out is, if you look at the very end of the problem, we're trying to figure out how many of each type of calculator were sold based on how many calculators were sold altogether, and based on the total amount of money that was involved and the price of the items. So the first thing we need to do is we need to define a variable for this problem. And so since we're trying to figure out how many of each type were sold, and we have scientific and we have graphing calculators, what we want to do is basically pick one of them to be our variable. So it really doesn't matter which. So I've decided I'm going to go with the scientific calculator. And so I'm just going to use S as my variable to represent this number of scientific calculators. All right. Again, you can pick any letter that you want. So in a word problem, I like to use a letter that corresponds to what it represents. That way we remember what our number deals with when we get to that solution when all is said and done. Now what we need to do is, we've got our variable for scientific, we got to figure out how do we represent then the other group, the graphing calculators. If we go back to the original problem, it told us that 100 calculators were sold. So we know that all together, when you put the scientific and the graphing calculators together, there were 100 total calculators. So if S represents the number of scientific calculators, the number of graphing calculators would be 100 minus that number. Okay, so this is where we come up with our expression for the graphing calculators, 100 minus S. All right, now notice that the key is, even though I've got two different groups of calculators, I'm still using the same variable in their representations. And that's kind of the key to these kind of problems, is figuring out how do you write things so that you're only using a single variable, because we haven't talked about how to solve two variable equations. We've just talked about how to solve variables that have, or equations, excuse me, that have one variable in them. So it takes a little bit of work, but once you get the hang of it, it gets a little bit easier. Now what we need to do is actually set up the equation for this problem. And the other pieces of information that we know is, we are given information about how much each calculator costs and the total cost. So here is the equation that I came up with for this problem. 18S, that first part, basically means we're going to take the number of scientific calculators and multiply it by the price per calculator. So 18 times S. And that piece of our problem tells us what the total amount was for the scientific calculators that were sold. Now the second chunk looks a little more complicated, but it's the same idea. 100 minus S represents the graphing calculator, so I'm going to take that times their individual cost, which is $90. So 90 times 100 minus S, the number of graphing calculators, gives you altogether how much the graphing calculators were sold for. And then finally, we add those two pieces together because we know that the total amount that the store brought in was the $3,240. So 18S represents how much was brought in for the scientific calculators, and then the 90 times 100 minus S represents how much was brought in for the graphing calculators. Adding them together then equals the total. All right, so now that I've got my equation set up, now we can go ahead and solve it. So we can get to kind of the meat of the problem in terms of coming up with what our solution is. So I've just rewritten the equation. Several things that we need to do in this case. One, we need to do some distributing. So if I do that first, we get 18s and then plus 9,000 minus 90s. So we got rid of the parentheses. Next, I can combine the like terms. So the 18s minus 90s is negative 72s. So be kind of careful with this situation. There are some negatives. Now I need to go ahead and work towards getting the s by itself. So I get rid of whatever's being added or subtracted. So I'm going to get rid of the positive or plus 9,000 by subtracting it. When I subtract 9,000 from both sides, I end up with negative 72s on the left, and then negative 5,760 on the right. Finally, we divide by negative 72 on both sides. The negatives cancel out, and I'm left with 80. So S equals 80. This is where it's important to recall what the variable represents, because that tells us then kind of what our number is talking about. S represented the number of scientific calculators that were sold. So this means we sold 80 scientific calculators. So if we go back to our problem, then we can look to actually then answer the question, how many of each type were sold? So our equation gave us the number of scientific that were sold, so that's 80. And then to find the number of graphing calculators, remember our expression was 100 minus the number of scientific, so 100 minus 80, so 20 graphing calculators were sold. And there we go. That is our answer that we're looking for. You can always go back and check your work by making sure that in this case, 80 and 20 adds up to 100. You can also do the math with the cost. So if I take 18 times 80 and 90 times 20 and add those up, I will get, if you take my word for it, we will get 3,240 for the total amount of money that was brought in, and we are good to go. So there is the solution that we are looking for. Let's do one more word problem for the video here, just to go through that process and make sure that you've got some good examples to look at. So this time, we're dealing with an hourly wage kind of situation. So again, I'll give you a second here to read the problem. Alrighty, so again, if you look at kind of the final question in the problem, how many hours did each person work? So we're looking for the number of hours that Bill worked, and then we're looking for the number of hours that his apprentice worked. So again, we want to define our variable and figure out what that is first. And again, there's two variables kind of happening. There's Bill and the apprentice. So we're going to pick one of them. So I'm going to go with B for Bill's hours. Okay. Now, to get the expression for the apprentice, we look at the kind of the second or third sentence here in the problem, and it says Bill worked 10 more hours than his apprentice. Okay. Now I know it can get a little bit confusing, but because we're starting with Bill and he works 10 more hours, if I want to come up with an expression that equals the apprentice's hours, I'm going to take and subtract. So I'm kind of actually doing the opposite of how it's written in the problem, because since Bill worked more, we got to subtract off of his amount to find the apprentice, because the apprentice worked less hours. So B minus 10 is going to be our expression for the apprentice's number of hours. Now the next step is to come up with what our equation is. And again, this is an hourly wage type of problem. So if you want to figure out the total amount that somebody earns, you multiply the hourly wage times the number of hours. So here's the equation, kind of similar to the last example problem in terms of the approach. 20 times B, Bill makes $20 an hour. So 20 times B would tell you how many, or how much, excuse me, Bill earns during the week. And then the same thing for that second part of the equation. B minus 10 is the apprentice hours. Take that times 16 to figure out how much the apprentice earns during the week. Add those two values together to get the total amount that was earned, the $1,136. All right, so now we can go ahead and solve our equation. So I'm just rewriting the problem. Again, we have some simplifying that we need to take care of by doing the distributive property. So we're going to go ahead and distribute the 16 through the parentheses, and that gives us the 20b plus 16b minus 160. We still need to finish simplifying by combining like terms. So the 20b and the 16b gets us 36b, and then the minus 160. Now that I've got a two-step equation, I continue working down my list of order of operations. So I get rid of whatever's being added or subtracted first. So I'm going to add 160 to both sides. So I end up with 36 equals 1,296. And then I get rid of the multiplication by dividing both sides by 36. And so B happens to also equal 36. 36 times 36 is 1,296. And so there we go, we've solved our equation. So now we go back to our original problem here and make sure we answer the question. We want to figure out how many hours did each person work. B represented the number of hours for Bill, so we've got that answer taken care of. Again, Bill worked 10 more hours than his apprentice, so if we take and subtract off the 10, 26 is the number of hours that the apprentice worked. Again, Bill's amount is 10 more than the apprentice's amount. If you want to double check then to make sure, we can make sure that the dollar amounts add up to what they're supposed to. So if you take 36 times 20, that'll give you how much Bill earns, which is $720. If I take 26 times 16, that'll tell you how much the apprentice earned. Add those two values together. And again, if you take my word for it, I double check the answer. Their total does in fact equal 1,136. And there's our solution. Those are the two numbers that we were looking for in the question. So there you go. We did a couple of example problems, and those are definitely some of the more complicated word problems that you need to solve. And again, what makes them tricky is the fact that there's two things that you're trying to find in each of those example problems. You were trying to find the number of hours for each person in that second example. There were two different parts to the answer. And so it can be a little tricky when you're solving those. And again, that's probably the most complicated type of word problem you will be asked to solve in this class. So if you can do these, you should be in good shape for solving most of the word problems that you're asked to solve in this class. So just kind of keep that in mind, that if you can do these, you're good to go for solving equations. If you have any questions about solving equations and solving word problems, please do not hesitate to let me know. I know it can be kind of a challenging process at times, especially with word problems, so please ask for help. I'm glad to assist you. But otherwise, if you are feeling good about things, that's great. Hopefully this video was helpful in just solidifying your understanding of solving word problems. And we'll call that good for this video. So let me know if you need anything. Otherwise, have a great day. Good luck as you work on the homeworks and get ready for the quiz. And we will catch you in the next video.